Okay, finally I make a new video, and this time it's about this A123 battery. You know, this is a 24 volt 20 amp hour battery made out of 8 A123 cells, and I have an older video describing the battery, but what I will do today in this video is discharging this battery and acquiring the data about the current and voltage, and build a graph about capacity of this battery. I will try to discharge the battery at about 0.5 C, or half the capacity per hour, so it should last for about 2 hours. This battery is about 500 watt hours, so I will try to discharge it with around 250 watt. I don't know if I will be able to, but I will use as a load these two 200 watt light bulbs, and then also I have the power inverter that has probably an efficiency of around, I don't know, I guess 80 to 85% efficient. This is a pure sine wave inverter. I will show you how it looks just now. So I will start with this. This is from the load side. I will have this as a load. Then I will have the kilowatt power meter connected to the inverter output, and then I will have the inverter. Then I have a bridge, not a bridge, then I have a shunt resistor to measure the current. Since these are normally high currents, I could not directly measure with a multimeter. And okay, next thing is the battery. Then the battery will be monitored by this little device here. I hope you can see it. This is a battery voltage meter, and what it does, it measures each cell, each of the 8 cells, and it has more display modes. It can measure with a 3-digit resolution, which should be sufficient for what I need. I hope you can see, so you can have all cells measured, and you can set some thresholds like low battery voltage. I set this to 3 volts, so I will discharge this battery until any one of the cells will reach 3 volts, and at which point I will stop the test for capacity. And you can also set a delta if somehow the cells will not discharge equally, and the difference is higher than the set delta in here. It will also trigger an alarm. It's an audio alarm, so it has a small buzzer inside, and you can connect a much stronger external buzzer if you need to. But for me, this internal one is enough for now. So this is that. And then I will have the Wavetek. This will measure the battery voltage, the total battery voltage. This on the front channel, and in the back you cannot see in the back of the unit, but in the back I have plugged the shunt resistor. This is 100 amp 75 millivolt, so it will output, it will have a voltage drop of 75 millivolt at 100 amp, and I will measure that with a separate channel that it's on the back of this unit, so I could measure two values at the same time. And then I will use the serial port of this Wavetek to transmit the data, and I will use a laptop. And since this is a newer laptop and it doesn't have a RS232 port, it only has USB, I got an USB to RS232 adapter, and I will have this connected to the laptop and to the RS232 port on the Wavetek. Of course, this is a TTL RS232, so 0 to 5 volt or 0 to 3.3 volt, and I needed to invert the signal from the Wavetek, and so I don't know if you are able to see here. I just made a small PCB with don't know what doesn't focus. It should focus. Okay, now it's an opto insulator here, and one resistor and a diode, because this opto insulator has two LEDs inside. Probably, I think they are infrared LEDs, and they are connected together. So since I have here plus minus 12 volt, this will switch on and off in on both sides, since it has two diodes back to back. But if you have just a normal opto insulator, it will work. It will actually work even with a simple transistor, but since I had this opto insulator, I use it to invert the signal. And I don't know if you will see on this screen. This is quite a small screen. I'll try to get the camera closer if possible. There's almost a mirror here. Not sure I can focus here. Yep. Okay. This is some test run that I did before, and as you can see, what I'm downloading from the Wavetek will be the back channel. This is 100, and it was no current here, that's why it's 0.00 millivolt DC. But when current will flow through the shunt resistor, then you will see here a value, and this is the battery voltage, what it was when I tested this. This is actually, I forgot to mention, this is Ubuntu, so Linux distribution, and this is I think this is the last, yeah, it's 12.04, so Ubuntu 12.04, and this is a terminal, so everything I will do will be in a terminal, and I will show you the commands that I used to store the data that come from the serial port to a file on the computer, and then I will use this file to build a graph. But what you get here is the value on the two channels. They both are voltages, but they could be converted to, one of them could be converted to current very easily, since it's what it's represent. And what I also have is a timestamp, so I know exactly at which time I recorded the data. So I will need to modify this, because this was, I think, every 5 seconds, but probably every 20 seconds will be good enough to build a graph. So I will change this in the Wavetek, and then I will come back, connect everything, and I will show you the results. And I will use this, like I said, the smaller brother of the 600 watt power inverter. It's exactly the same, it has exactly the same digital circuit, and it just has a smaller transformer, and it's only rated for 300 watt continuous output. And I will use this one since I only use 200 watt light bulbs, and it will be an overkill to use the 600 watt one. So okay, so this is the STTI command to set the serial port. In my case it's TTI USB 0, and it's set at 9.6 K, just because the baud rate, just because it is fast enough for what I need, just downloading some numbers every 20 seconds, so I don't need a faster connection. And the other one, it's this one, not this one actually. Yeah, okay. So this one will print on terminal, like you've seen last time. You just need to wait about 20 seconds, it should run. I think you can hear the clicks from the relays, maybe quite strong, because the microphone, the recorder, is on top of the Wavetek. But as you can see, I did not start the load, so there is no current, but this is the battery voltage at start, and you see, you get the values and the time, and as you can see, there is about 20 seconds in between data acquisition, so it should work fine. But this is printed on terminal, and I want to save it on a file, so I will stop this with Ctrl C, and then to save it on a file you just do this, and let's say doc test.txt. I will save it in a text file, so, and I will just start recording now. And as you can maybe see here, a file was created with this name, and inside this data will be saved. So okay, I will go now to show you the Wavetek display. Okay, so this is what you see on the display. It's, I don't know if you can see this display from this angle. Yeah, now it should be better. And as you can see, the first value is the voltage drop on the shunt resistor that I used, the 100 amp, and this other one, it's the battery voltage. So I think everything is set now, and I will try to start the inverter. I used the 300 watt inverter like I mentioned. So this is the complete setup. I don't know if you can see it, this one. And I will try to start this to see if everything works. Yep, seems it works or not. Let's see what's going on. Okay, should, so there are about 191 watt. Okay, and I can calculate how much current through. So it's 6.862 millivolt. 6.872 now. Okay, multiplied 1.33. So this is the current, 9.16 amps. 9.16 multiplied with what's now 26.7, about 244 watt. So just about 0.5 C of the battery capacity, so half the battery capacity. That's around 500 watt hour. And this should run for probably close to 2 hours, I hope. And maybe less, I don't know, depends if the capacity is really 500 watt hour or not. And when this is done, I will do a graph and show you the results. The fan is just about to start on the inverter, so I just wanted to show you the noise made by the inverter. It's not that much noise, but it's a small fan, so it's temperature controlled, so it will probably kick off at 200 watt in, I think, not sure exactly how much time it passed from when I started, but something like 2 or 3 minutes and the fan's already running. It's quite noisy. This is actually first time when I test this long term. I just tested to see if it works or not, but it seems good quality. It will probably have there will be no problem with it. At 200 watt it's quite a lot under the 300 watt coated. Okay, just wanted to show you that this battery monitor seems to be quite confused. There are a lot of variation in readings for each cell, but it seems to do fine. So now it's probably because of the noise introduced by the inverter that this is happening. I'm not sure. Anyway, the indication seems to be fine, and you see the delta, it's quite small. It's around 20 millivolts between each cell, so everything is running smoothly. This about 10-12 minutes into the test. Okay, so the voltage on one of the cells, I see cell 1, dropped under 3 volt. So I will stop the tests here. I'll just show you. I don't know if you can see. Total output power 370 watt hour, maybe 380, I don't know. But this is the output from the inverter, from the battery must be more, because the inverter it's about I don't know, 85% efficient or something like that. I will make a more precise calculation. So you can see here 2.95 volt on cell 1 and 2. So I will stop this test, and total battery voltage 24.34 right now. This is maybe about 3 or 4 minutes after I stopped the test and disconnected the load, and as you can see, the voltage on 3 of the cell didn't recover above 3 volt. Actually, it's only 2 of the cells. I don't know why the cell 6 it's flashing, because I see it's over 3.1 volt. No idea, maybe that yeah, I think that one is the highest one. Yeah, and it's flashing because the difference between the highest one and the lower two, it's higher than 100 millivolt. That was the maximum delta I allowed. The lower voltage on cell 1 and 2 can also be due to the fact that this cell battery voltage meter it's using about 30 milliamp, which I think it's quite high, and it's only using power from the first 2 cells, not the other 6 of them. So if you leave this for, I think, a month or something like that, 4 weeks, it will probably completely discharge cell 1 and 2 just by having this as a load. So I don't think they did a very good job in this regard. I mean, the power consumption for this device should be much lower, at least 3 or 4 times lower. But for $12 or something like that, you cannot complain. After I made the discharge, I also recharged the batteries using this constant current, constant voltage power supply that I got on eBay recently for about $50. I think now they are a bit cheaper, since this was a new product. And it seems to work quite well. It's quite good. It can output up to 60 volt, depending on the input, of course, and 5 amps. And it's using a P-channel MOSFET as a driver. I think it's an IRF 9540 or something like that. It's a P-channel MOSFET, and that one, it gets a bit hot, but it's probably nothing to worry about. But I don't like to have anything hotter than 50-55 degrees Celsius, since I usually like to oversize things, so I don't like to have hot things. So I will probably use a larger heatsink in the future, and I will take this MOSFET and put it somewhere on a larger heatsink, maybe even use 2 of these MOSFETs in parallel. So anyway, this time I used 4 amps. Like you see, it's 3.996. You cannot digitally set the output voltage and limit current. You will use this. If you see on the right side, there are two variable resistors. I think they are 10 turn or something like that, and you use those two to set the output voltage and current limit. And but there are a lot of other features. You can set the you can put a limit for output amp hour if you charge batteries, or you can set a certain time, or you can do a lot of things with this power supply. So I think it's quite good. I like it. And I also used two AC adapters in series. They are 19 volt each. So, but since they are not electrically insulated inside, you cannot directly connect them in series. So I used, for one of them, I used an isolating transformer. So that way I could connect them in series for a total of about 36 volt. And I set the output, I think, at 28 volt or 27.8 or something like that. Not very important. So I will get about 3.5 volt per cell if they will charge equally. And okay, so this is what I used to charge them. It took about 4.5 hours, because I did before this, I did about a half an hour charge at 2 amps, so about 1 amp hour was already in the batteries before I started this charging test. So it's not exactly from the start, but it's good enough. And as you can see, the constant current limit LED, it's on. So now I was charging the batteries. I was putting about 104.6 watt into the batteries. And this is the cell battery voltage meter. Just, I think, 10 or 20 minutes after I start charging the batteries. I don't remember exactly, maybe half an hour anyway, at the beginning of the charge. And you can see that cell, the difference between the 8 cell voltage is not higher than 5 millivolt. So during charging they are quite equalized. And here is a picture that I took at the end of the charge. As you can see, it was about 17.5 amp hour, and it's quite accurate from my calculation, from the data that I got from the Wavetek. It was about 17.4 amp hour, so it's quite close. I think the indication it's good. And this is the cell voltages at the end of charge, and as you can see, it exceeded 100 millivolt. The alarm was set for 100 millivolt, so the alarm was working when I took this screenshot. So you can use this even to charge the batteries, since you can set an alarm for a delta between cells, and usually one of the cells will charge faster than the others, and at the end of the charge the voltage increases rapidly. So even if it's just 0.1% difference between cells, you will have one battery that will charge faster, so it will set the alarm on this battery meter. And now I will make a part 2 of this video with the results for charging and discharging of these batteries. And since this video will be quite long, I want to make a separate video for the results. If you are not interested in the setup, you just go to part 2 of the video and see the results. Okay, thanks for watching this video, and don't forget to check the part 2 of this video with the results. It should be there. If you've seen this video, the part 2 should be also there, because I will upload it at the same time.